Look, ladies and gentlemen, this is just because we got some time. Right on top, division by 0. Why is it commandment number 1 over there in the 10 commandments of mathematics that you cannot divide by 0? Why can you not divide by 0? Abram?
It's impossible.
What about why? Tyler?
Because if you have a number and you try to divide that by 0, it's going to be 0. But 0 times 0 is not that number. Like if you try to divide 16 by 0.
Alright, well let's look at, I think you're on the right path. If you look at, let's look at a normal division problem. 16 divided by 2 is 8, correct?
Yes.
Which simply means this. Division is just the inverse property of multiplication. In other words, these two times themselves will give you that top number. But if you look at, and this is where you need to make sure you have some notes on this, you can always have a 0 on the top. 0 divided by 3. What number would you multiply 3 by to get 0?
0.
This is possible. Zeros can be on tops of fractions. Okay, because you're dividing, it looks like this, 0 divided by 3. And that's 0. 0 times 3 is 0. However, ladies and gentlemen, if you put the 0 on the bottom, you are asking yourself, what number would you multiply by 0 to get 3? And you know that's impossible because of the 0 property of multiplication, which says that 0 times anything is always 0. There is no number that you can put in here that will ever work. It's impossible. We actually call it undefined. Undefined. Now, taking that one step algebraically farther, they are going to ask you, or they'll give you something like this. When you have complicated mathematical problems and you end up with something like this, y equals 5 over x, which if you remember is our little formula for inverse variation, okay? You must recognize immediately that if you do this, you can't have a 0 on the bottom. So you have to kind of note that off to the side where x cannot equal 0. And if you remember, we did the graph of this thing. If you do the graph of this thing, do you remember what it looked like? Does everyone remember what it looked like? That's...
No, it was like a
Sideways view.
yeah. It's like going out from the y all the way down but not touching the origin.
It's a disjointed graph, I believe. You know, well, let me put some numbers in there that work. If x is 5, y is 1, right? If x is 1, y is 5. Is anything else that works? If x is, I don't know. If x is 3, y is 5/3. If x is, well, what if x is -1? What's y? Yes, -5, thank you. What if x is -5? -1. If you're graphing this, 1, 5, 1, 1, 2, 3, 4, 5, you get this little dot here. 5, 1 is 1, 2, 3, 4, 5, 1. 3, 5/3, 1, 2, 3. 5/3 is the same as 1 2/3, which would be about right here. And if you did this out, you end up with this. This is what these boys were talking about. But not only do you end up with that, you also end up with its mirror image on in this 1 2/3 quadrant. That looks like this. You get that little goofy thing. Now, in addition to that, children, this is a simplified one, but what if this happens? What if y equals 3 over x minus 2? If it gets a little more complicated, you have to be able to say what can you not allow x to be, because it will be undefined when x is that number. What? All you're asking yourself is this. When will you get a 0 on the bottom when x is what number?
2.
2. But you have to show that when you do this that x can never equal 2 because that is undefined. Or if it was y equals 3m over 3x minus 5. That's usually one that throws somebody for a loop. Again, you can't get x on the bottom, so you have to figure out what would x be to give you 0 on the bottom there. Somebody in here I know is going to figure this out. Savage. No, if x was 5, you get 15 minus 5 and get 10 on the bottom. People use your mathematical capabilities. Wait, Ellen's going to get this, which I'll say yes, nice work. Wade says 5/3. Wade, how does one get 5/3? Because I believe you're right.
Because you divide by 3 to cancel out the 3 and then it's
I think you're thinking here. You
Negative
want to
5.
know this, children. Take a look. Here's the thing you don't want to be 0, right? So off to the side here, say, okay, when will 3x minus 5 be 0? Because that's what I don't want. It's an equation. You just need to solve it. Add 5, get this to the other side. Divide by 3, divide by 3. When x is 5/3, you'll get 0 there. So you say x cannot equal 5/3 because that'll give me a 0 on the bottom of my fraction. And I can't have that. You are mathematicians. Should we try one more? Sure. One last one, just for fun. Here's one. How about this? 16 over x squared minus 4. If y equals that, what cannot x be? When will you get a 0 on the bottom? When x is
2 or negative 2.
y.
Because if you add 4 and 4,
You take x squared minus 4 and set it equal to 0, you get x squared equals 4. Take the square root of both sides, and x cannot equal either 2 or negative 2. Here or there. That is as exciting as life gets. We shall go no farther with that. Wait,
so on 18 would we
wait,
graph
problem
it
18 where?
in our
On this
have to-
problem?
I know, but like that's the problem for this, right?
Which 18 where?
In the lesson we just did.
Oh no. Let me stop this first. No, that was not